Hello. In this video, we introduce the basics of a new language called logic. Just like any language, you need to learn the basics, the grammar, the punctuation, the vocabulary. So let's get started with statements and logical connectives together. So when we're describing a logical statement, just like in algebra, you use x and y to talk about variables. In logic, you use the letters P, sorry about that. You're going to use the letters P, Q, R, and S to describe your statements, P, Q, R, and S. Those are going to be simple statements that we could then combine. So we say we're writing these simple statements logically. Okay, so we use the letters P, Q, R, and S to write our simple statements logically. And then we'll be combining them into compound statements. That's our next fill in the blank here. Compound statements by using different symbols, some connectives, if you will. Just like in the English language, we have the word and, we have the word or. Here we're going to have symbols that represent the same idea. So let's think of some simple statements that we could rewrite in logical symbols. For example, let's look at the statement, Juan likes coffee. I'm going to call that statement P. So statement P will represent Juan likes coffee. And I'm going to call Juan likes tea the statement Q, and Juan likes soda the statement R. So very simple statements, just your subject and your verb, basically. Okay, so now what we're going to do is combine those simple statements by practicing using our new connectives. And I highly recommend that you have your notes out, you're taking good notes, and I highly recommend that you memorize these connectives. Okay, so take the time to maybe either make note cards or just memorize by singing them, whatever you want to do, writing them. Make sure that you understand which connective goes with each type of symbol. So the first connective that we see is this little tilde here. And this tilde is called our negation. And it means not. So the way that we see this happen is we'll see a letter like P, and then you'll see the tilde go in front of it. And we read this as not P, or negation of P. So negation just means take the opposite, or it's not true, so say it in the opposite way. So you'll see, for example, let's go down to my third point here, negation of Q. Okay, so the negation of Q would say take the opposite of what Q says right now. So what did statement Q mean right now? It meant Juan likes tea. So what would it mean to see the negation of Q? You could say it is not the case that Juan likes tea. That's a very fancy way of saying it. But most people would probably just say Juan does not like tea. Right? That would negate the original statement, Juan likes tea. Okay? Let's look at another symbol here that we need to get used to. And that is our conjunction symbol here. So what is a conjunction? Well, in the English language, a conjunction is typically when you put your two simple statements together with the word and or but. Okay? And so you might even want to add to your notes here, this could also be the word but in the English language, right? And or but. And we're going to use this symbol here that looks like an arrow pointing up. So an arrow pointing up is going to be our conjunction symbol. And the way you'll see it written in logical notation will be one logical letter, P, in this case, and then another logical letter, like Q, but in between the two letters, you'll see the conjunction symbol. So remember, with the negation, that goes before your actual statement. It goes before the letter, like P, so it was negation of P. In this case, it goes in between them, okay, because you're combining your two simple statements here. So we have P and Q, for example. So let's take a look at our first practice application with this, P and Q, with our statements, Juan likes coffee, Juan likes tea, and Juan likes soda. What would P and Q mean? Well, you could say Juan likes coffee and Juan likes tea, but most people would shorten that, right? They would just say Juan likes coffee and tea. Okay, so that's the idea of putting the two simple statements P and Q together with the conjunction symbol, so that facing up arrow. Okay, let's see our next symbol that we need to memorize here, and that would be our disjunction symbol. So the disjunction is another way of connecting two simple statements, but instead of saying you have to have P and Q both being true, it's the case where just one of them has to be true. So this has to be true, or this has to be true. So that's our upside down arrow, or our arrow pointing down, if you will. It looks like the letter V, right? And it's read or, and it works the same way as a conjunction, except for the disjunction means or, and it's an arrow pointing down, like a V shape. So what does P or Q mean? Let's go to our second application here. What does P or Q mean in this particular situation? Can you take a moment and pause the video and see if you can write it correctly? If you said Juan likes coffee or Juan likes tea, you would be correct. Also, if you said Juan likes coffee or tea, you would be correct. Well done. This might seem very basic right now, and I hope it does, but it will be important to have all of these building blocks really down pat as things get more complicated. Okay, the next connective that we're going to introduce is a little more complicated for my students typically, and that is the conditional. And I've kind of been using the conditional symbol in each of my examples here, and it's an arrow pointing to the right, a single arrow pointing to the right. So the conditional arrow, if you will, pointing to the right, it means if something happens, then something follows. The reason it's called a conditional statement is in order for the expectation to occur, the condition initially must have been satisfied or met. So this is what we mean by an if-then statement. For example, like I say, if you do all your homework, then you'll get an allowance, something like that. So you don't get an allowance unless you do all your homework. There's a condition here, okay? So conditional statements in logical symbols will occur when you see the arrow pointing to the right, but you actually have the two letters that represent your simple statements before and after that arrow. The first one is important. The order matters here. The first statement is called your antecedent. You feel free to write that in your notes. Antecedent, A-N-T-E-C-E-D-E-N-T. The antecedent is the conditional part of the statement. If that condition is met, then the expectation will follow. The expectation here, we're calling letter Q, is called the consequent. So it's kind of like a consequence, but we use the T at the end, consequent. Okay, so if P, then Q. So how would we rewrite the conditional situation here based on our example with Juan liking different types of drinks? If P, then Q, what would that be? So the first thing you need to put is the word if. Good job. If, and then you say, what was the P? P was Juan likes coffee. So if Juan likes coffee, then you put comma, that's the end of the condition. Then he also likes what? Tea. Then he likes tea. Usually we put the word also there, but you don't have to. You can just say, if Juan likes coffee, then he also likes tea, or then he likes tea, all right? Now again, you might say that's not necessarily true. Just because someone likes coffee doesn't mean they like tea. Well, right now we're not talking about the veracity of the statement, whether it's true or false. We will get to that. But right now I just wanted you to see what these symbols would mean, okay? One more that we need to talk about is called the biconditional, the biconditional. So the biconditional also has an arrow, but not just a one-sided arrow, a two-sided arrow. It's called a biconditional, bi meaning two. What does that mean? Well, that means that there are two conditions which are related to each other. The way we think of this is the first condition makes the second happen, but the second condition also makes the first one happen, right? Most humans actually incorrectly think that an if-then statement goes both ways, but they usually don't. If-then statements typically only go one direction, like we just talked about. The biconditional is that special case where both of them imply the other. The way we're going to read this in English is if and only if. If and only if. And sometimes you'll see in capital letters IFF in some textbooks, and that will mean if and only if. So when you see the biconditional, the double arrow, it will be in between the two letters, like P and Q, and it's telling you that if P happens, Q must follow. But also if Q happens, P must follow. So they make each other happen, right? They are both sufficient to cause the other to happen. And they're both necessary for the other to happen, okay? So they're necessary and sufficient. Okay, so this is called a biconditional. So how would we interpret in English this logical statement? P double arrow R. What does that say in English? It means P happens if and only if R happens. So P was Juan likes coffee. So I would start with Juan likes coffee. I'm going to probably run out of space here. The next thing you would want to write is if and only if he likes R, which was soda. So I'm going to go ahead and use that shortcut for a second. IFF, if and only if he likes soda. I'll just move that out of the way for a second. Okay. So Juan likes coffee if and only if he likes soda. In practical lingo, what this is saying is if you are talking about your friend Juan and someone says, hey, does Juan like coffee? Yes, then we know he also likes soda. Or if someone says, does Juan like soda? Yes, well then we know he also likes coffee. And it goes the other direction as well. If he doesn't like one of these, then he doesn't like the other. So we'll talk more about the truthfulness or the falsehoods of each of these in future lessons, but today we just want to learn the basics of the grammar of logic. So make sure you have note cards, that these are in your notes, and you practice each of these symbols so you can recognize what they're saying before we start analyzing the truth or the falsehood that we're dealing with. Okay, so now we're going to put that to use in our next example, where we will be basically writing down how to take a logical statement from symbols to words. So here we have example 1. Write in words these compound statements where P is the statement Juan likes coffee, Q is the statement Juan likes tea, and R is the statement Juan likes soda. Now in part A, it says parentheses, P and, remember that and symbol, it's our conjunction, Q, close parentheses, or R. So how would I rewrite that in English? Maybe you already know, feel free to pause the video and try it yourself. So if this were me, I would begin by noticing that P and Q are in parentheses, meaning that that conjunction needs to happen together, and in English, we use a comma, right, to indicate that something has been grouped together before we proceed to the next thought. So we're going to write here, Juan likes coffee. And you could also say, and Juan likes tea. That would be the Q statement. But we could just say, he likes tea to save writing. Or just, he likes coffee and tea. That would also have been fine. And then we put our comma here to indicate that's the end of the first thought, that first group. Okay? Or, and sometimes in English we'll use the word else, so I'll put that in parentheses when we use an either or statement. So, or else, he likes soda, because that is statement R, right? So this is saying he likes coffee and tea, both, right? He likes both of those things, or else we know he likes soda. Now, with the or statement, keep in mind, only one of them has to be true for that to be a true statement. We'll talk more about that in future videos, okay? Let's check on our next statement. How would I translate these symbols into words? It says Q, and then it has a single arrow pointing to the right. That's an if-then arrow. Then it has parentheses, P, double arrow, our biconditional, R, close parentheses. So as soon as I see that arrow here, that is an if-then. So for me, I'm going to write if something, comma, then something. That's going to be my setup. Let me make a little more space there for you to see. If, then. Okay? So if what? If Q, so if Juan likes tea, and I can move my comma up here now because I was a little overdramatic with how much room I would need. If Juan likes tea, then he likes coffee. If and only if he likes soda. Okay? So if Juan likes tea, then that would mean that he has to like coffee if and only if he likes soda. Meaning if he likes coffee, he likes soda, and if he doesn't like coffee, then he doesn't like soda. Those are tied together. All right, so if we can go in that direction, do you think we can go in the other direction? So instead of symbols to words, words to symbols? Let's check out our next example. In example 2, it says, write the compound logical statement symbolically. It says in part A, if it does not rain today, then I will not stay in, but will go jogging instead. All right, so if you think you know what to do, go ahead and pause the video and try this one yourself. So the very first thing I would recommend is to identify what are my simple statements. So the basic ideas, subject, verb, right? First thing I notice is I have an if-then statement, so I'm going to have an arrow, right? I'm going to have my connective that way. And I notice one idea is being rainy, okay? And another idea is staying in. And another idea is going jogging. So I have 3 basic ideas here. It's raining today, I'm staying in, and I go jogging. So if I keep that in mind, raining could be like statement P, staying in could be statement Q, Going jogging could be statement R. How could I write this into a symbolic statement? Well, because of the if-then, I'm going to need an arrow pointing to the right, right? That's my if-then symbol. So if it does not rain today, so not just P, but negation of P, if that happens, something else should follow. Well, what should follow? It looks like after that comma, everything else goes together. So we're going to put parentheses around everything else that's coming. What happens if it does not rain today? Well, I will not stay in, but I will go jogging instead. So not staying in would be the negation of Q. That's not staying in. Remember, the word but can also be interpreted as the connective or the conjunction and, right? So the and symbol is the arrow going up, right? And I go jogging, that would just be letter R. So symbolically, here's what we have. Not P, if the if-then arrow or the conditional arrow to the right, parentheses, negation of Q, and R, close parentheses. Notice the importance of the parentheses there. If you did not write the parentheses, you would be telling the reader, they would be being told that if it does not rain, the only thing that's guaranteed is that you don't stay in, okay? And then you mention, oh, by the way, I went jogging, okay? But by putting the parentheses there, we're telling the reader, if it does not rain, two things will both happen. I will not stay in, and I will go jogging, okay? So that parentheses is very important. Try B on your own if you think you're up to it. Okay, so for B here it says, you received an A in the course if and only if you earned an A you earned a 90 rather in the course. So you received an A, that's one idea. You earned a 90 in the course, that's another idea. And then we have the connective if and only if. So if receiving an A at the end of the semester, if we call that statement P, and earning a 90 throughout the course, if we call that statement Q, how would I have written this symbolically? If you said P double arrow, which is your biconditional, Q, you would be correct. That would be the symbolic version of this English sentence, right? We've now taken P, we've taken Q, and we've connected them with the biconditional arrow, meaning if one happens, the other happens, and if one does not happen, the other does not happen. All right, so I really encourage you to practice going back and forth between simple statements in English and simple statements with logical connectives and symbols. All right, let's try our next slide and continue building on this. So on our next slide, we want to introduce the idea of a quantified statement that we will negate, okay? When I say a quantified statement, I'm talking about words like all or some or none or some or not. These are the words we're describing when we say quantified statements. So now what we're talking about is wanting to negate them. So how do I negate one of these words? In other words, how do I say that is not the case? Okay? So for example, let's consider the all type of statements. So if someone says to you, all humans like coffee. Well, you might think that's not true, right? In order to show that that's not true, to negate the statement, do you have to show that every human, so if I said all humans like coffee, do you have to show that there are no humans that like coffee? No, that would be too strong. All you would have to show is that there is a human who does not like coffee. In other words, some humans do not like coffee, or some humans are not coffee lovers, right? So the negation of an all statement is not none. That's really important. I write that in my notes. It is some are not, or some do not, if it was all do something, right? Some do not, some are not, okay? Or at least one person is not, something like this. So you only need to show that there is one that does not fit into that category in order to disprove or to negate an all statement. Similarly, if someone mentions the phrase, none, or nobody, or no one, right? If they say, nobody passed that test, well, do you have to show that everybody passed the test in order for that to be a negated statement? No, you just have to find me one person who did pass the test, or someone who did. So the negation of a none statement is some are, some do, right? Someone is, okay? Someone did, that's the idea. So I would really encourage you to make flashcards or memorize this however you best learn so that you don't fall for that trap of trying to actually negate something with more evidence than you need, okay? So let's take, for example, a look at this sentence. Some cats are dogs. Now, regardless of you think it's true or false right now, how would someone negate this statement? How would someone show that this is not true? Using logic, right? So if someone says some cats are dogs, how do I negate that statement? How do I negate that quantified statement? Take a look at the notes if you need to. Pause the video to see if you write down the answer correctly. So did you say that no cats are dogs? If you did, you would be correct, right? Because the negation of some is none or no one, okay? So again, making sure that you don't overdo it. You don't have to prove that everything is the opposite of what I have. You just have to show that there is one case to disprove a none or an all, vice versa. Okay, so let's take a look at our next slide, putting this all to practice. In example 3, it says, can you write the negation of each quantified statement? And again, I encourage you to try to practice this on your own by pausing the video. All right, so if I want to negate the following statement. In statement A, it says, no one got a perfect test paper. I kind of did this one earlier, so you should already know the answer. What was it? Someone, good job. Someone did get, or someone got, a perfect paper. Good job. Now notice here what I did not do. I did not need to say everybody got a perfect paper. That's too strong. I only needed to show that the negation of a none is a some. Okay. What about negating statement B, if you haven't already done so yourself? All students do their homework, or all students did their homework. What would the negation of that be? How about some students did not do their homework? Would that work? Yeah, because the negation of an all is some did not. Notice I did not need to say that no students did their homework. To negate an all statement, I just needed to say there were some that did not do that. Okay, so hopefully that's starting to make more sense. How do I negate a quantified statement? Make sure your notes are really clear, and of course, if you have questions, feel free to ask. Well, at this point, we've now introduced the basic idea of how to write a logical statement in symbols, and then how to translate that back into English, and how to negate quantified statements like all or none or some. So at this point, it's up to you to go practice, because math is not a spectator sport. I'll see you next time.